Hello friends, sometimes in examination, some bacterial growth related microbiology and biotech problems appear in this way. Regarding the bacterial culture in a culture agar plate, you have nutrition mediums and it is being diluted to isolate the certain amount of bacteria from a colony or sample. So sometimes this kind of question appear with the dilution factor, dilution, concentration, colony formation, and with the number of colonies, we have to calculate the cell number from the initial stock. So in TIFR JGE bills in 2019, we had a question like how many bacteria were there in the initial 1 ml of sample based on the dilution series. So what is the main thing? You have a sample stock solution. So now you are taking a certain amount of solution, 1 ml out of it, and you are continuing the dilution process in a series. Like you have a total 6 stages of dilution, and finally you are taking 10 microliter. 10 microliter means you have to first convert it into the ml. So 10 into 10 to the power minus 6. Micro is a 10 to the power 6th order, then 1000. So it will be 0.01 ml. Correct? 1, 3, 10 to the power minus 4, 10 to the power 4 into 10 to the power minus 6. It will be 10 to the power minus 2. So it is equals to 0.01 ml. Now what you are getting 65 colonies. The levels below the tube shows the amount of liquid before the transfer. Assume no cell death. We are referring this one, there is a no cell death during the transfer, and assume that all bacteria successfully form the colonies when placed. Then you have to find the number of bacteria, how many bacteria are present in the initial phase. So simply we'll use very basic formula. Like if I use this one, concentration of the bacteria is equals to the concentration at length finally after dilution, that is Cx. So that is the concentration, that is Cx into the dilution factor. So simple equation we have to use, that is the Cx into df. Now how to calculate Cx is equals to 65 colonies that we have got divided by 0.01 ml. So it is equals to 6500. This is the total number of cell, that means this is the colonies. So how many colony forming units are there? So that is the concentration. So Cx equals to 65 divided by whatever the number. Suppose this is 0.01 ml. So you divide 65 by 0.01. If it is in 1 ml, that means 65. So this is this colony forming unit per ml. Correct? So we can convert it later on into the number of cells. Let's see how. Next, we will go for the dilution. Now you see, if you want to calculate the dilution factor, it is just reciprocal of the dilution. Dilution factor is nothing but the reciprocal of the dilution. Now go for the dilution one by one. First you have transferred 1 ml. The first dilution is being calculated by the transfer amount by the total volume. So transfer amount we will take 1 ml. So that is divided by total amount 9 plus 1. That is 10. Now total dilution factor is the product of all dilutions that has been executed. So D1 into D2 into D3 into D4 into D5 into D6. So subsequent total multiplication of this dilution will give you the total dilution factor. Now same way 0.5 amount has been transferred to the next test tube and the total amount is 4.5 plus 0.5, that is equals to 5. The same way it is 3 ml plus 27. So total 3 plus 27 is the total amount. So 30 ml is the total, then 3. In the same way we will go 1 ml. So that is 1 ml is the transfer amount, then 99 plus 1 is the 100 ml. Now again you have transferred 2 ml out of it and total amount will be 80 plus 2. So that is your 20 ml. Now finally you have taken 10 microliter in the culture plate. So see how many dilution factors you have taken. 1, 2, 3, 4, 5. You have missed someone. 1 plus 9, correct? 4.5 plus 0.5, then 27 plus 3 plus 99 plus 1. You have missed this one, 9 ml and 1 ml. So in between it will come, 1 by, so 9 plus 1 equals to 10. So we have taken all 1, 2, 3, 4, 5, 6. Now you take the product of it. If you take the product of it, it will come as 1 by 10 into half by 5. That means 1 by 10. 3 by 30 is 1 by 10. 1 by 100. 1 by 10 again. Then 2 by 20 equals to 1 by 10. So continuously we have taken. So first, second, third, fourth. Fourth one is a 1 by 100, then 1 by 10. So total it is equals to 10 to the power minus 1, 2, 3, 4, 5, 6, 7. 10 to the power minus 7. So this is the amount of dilution. Now if you take the reciprocal of it, that means 10 to the power 7. That is the dilution factor. So simply what we have to do, we have to find out the dilution factor and multiply with the concentration, that is a Cx, that is 6500. So we shall be getting 6.5 into 10 to the power 10. This is the total number of cells. This is how we have to proceed. So 6.5 into 10 to the power 10. This is the way we have to address the problem. Okay, so this kind of transfer of bacteria through liquids is normally executed in the microbiology and biotech experiment. One thing we have to remember, the flocks that one, the colonies is not equals to the number of cells. So if I say like a number of cell is a x, it is in the 1 ml. So x by 1, that is equals to the total concentration. So this concentration is nothing but the amount of colony forming unit per ml. So if I say concentration is x, that means there are x colony forming unit in 1 ml. So if I say number of cell is 1000 in 0.1 ml, so just we divide 1000 number of cell by the amount, then we shall get the concentration or the colony forming unit per ml. So this is how the conversion actually takes place. In examination you can get few transfer like in buffer medium 1 to second. So just we have to remind, this dilution factor is not always constant. Sometimes it is 1 by 10, sometimes it's 1 by 1000. So depending on the dilution factor and the concentration, it will vary. Simply you can get the initial concentration by multiplying. It is the product of nothing but the product of dilution factor and the concentration. I hope this will help you. If you like this one and if you get benefit out of it, please share and subscribe to my channel. Thank you for listening. Stay tuned, stay healthy and stay happy.